In a parallel circuit, each component has an independent path back to the voltage source. The three light bulbs in this video soon will be connected in parallel to each other and then to the voltage source. If one bulb is crushed or burns out, the other two bulbs will remain lit. This is because each of the remaining bulbs has an uninterrupted path back to the source. We will now go over some sample circuits and try to find unknown values. This is a series circuit. There's a single path for current and there is no branching. Given the two known resistors, we will find the total resistance that determines the circuit's current. To find the total resistance, we simply use an equation that's on your reference table. It says that the total resistance is the sum of the individual resistors. So we have 1 ohms and 2 ohms, so the total resistance is 3 ohms. Now that we have the total resistance, we can find the total current using Ohm's law. This gives us a total current of 4 amps. This means that there is 4 amps coming out of the source and moving through the two resistors. Now we can use Ohm's law to find the voltage drop caused by the two resistors. To get the first voltage drop, we multiply the total current we just found by the resistance and get 8 volts. When we use Ohm's law on the second resistor, we get a potential difference or voltage drop of 4 volts. Now let's take a look at a parallel circuit. There are 10 amps coming out of the voltage source that's split up into 3 branches. We are asked to find the total resistance and have the total voltage and current. The easiest way to do this is to use Ohm's law. Now we are asked to find the current in the first resistor, given that the source voltage is 60 volts. This makes the first voltage drop, V1, 60 volts too. Using Ohm's law and the value of the first resistor, we get a current of 3 amps. We are now asked to find I3, the current in the third branch. Like the previous problem, we begin by noting that the third voltage drop, or potential difference, is equal to the source voltage, which is 60 volts. Since we know V3 and R3, we can use Ohm's law to find the third current, which is called I3. When we divide both sides by 30 ohms, we get a current of 2 amps. Before we find resistance R2, we must find the second current called I2. Since we know the total current is 10 amps and the currents in the first and third resistor add up to 5, the current I2 must be equal to 5 amps. Before we find R2, let's go over what we've done so far. The voltage drop in each branch is equal to the source voltage. We use Ohm's law to find the current in the first and third resistor. We use the total current to find the current in the second resistor. Now we use Ohm's law to find the value of the second resistor. This is the end of my presentation on how to use Ohm's law to find unknown currents, voltages, and resistance in a series or parallel circuit.